Hi, everybody. My name is Jason Morris. I am the Director of Rules as Code for Service Canada. And what that means is that I'm working inside a department of Service Canada called the Benefits Delivery Modernization Program. And my job there is to help them explore how they can use rules as code to enhance the way that they deliver benefit programs primarily to Canadians. So I'm going to be talking a little bit about an experiment that we did trying to use Open Fisca to power a legal expert system. Little brief background for those of you who aren't familiar with rules as code. Rules as code is a method of public administration that involves digitizing rules as quickly as you possibly can in the life cycle of rules. So that means basically as soon as you start thinking about a policy that you would like to implement, that's the time to start encoding the rules for that policy. And that encoding becomes a part of the drafting process. It becomes a part of the policy development process. It becomes a part of how you build software. And then you can publish that encoding and it becomes a part of how other people write compliance software. And so it's supposed to enhance all of those capabilities in the life cycle of a policy idea to implementation. And for us, we were working on a tool called the Eligibility Estimator. And this was based on a law called the Old Age Security Act, which had 4 different benefits inside it. And the idea was that we wanted to generate an app that would give people some information about which of those 4 benefits, if any, they qualified for and in what amounts. And I came in after the process was already underway. So they already kind of knew what they wanted the app to be able to do. And I just talked to the developers and I said, if I was going to build a rules as code backend for this, what features would it need to have? And they told me that it would need to answer questions like, do I qualify? And if so, for how much? It would need to be able to guide the interview in the front end by saying what additional inputs would be relevant to collect if it didn't yet know what the answer was. It would need to be able to give contingent answers because there were some things that the system knew were relevant, but it also knew it was not realistic to collect those facts from the users. So there were going to be some situations where the answer would be, you qualify as long as this thing is true, which we don't really know. And then they also wanted it to be able to do legally justified explanations for the conclusions. So say what the answer is, say why the answer is, and then tie that why back to the source legislation, which is the fundamental point of rules as code, is that your laws actually become source code for the application. So you can refer all the way back to the actual law. And then they knew what the set of inputs was that they were going to be using, and I needed to be able to handle those. So that was my task, is to kind of build a duplicate back end for this application using a rules as code approach to see if I could make it work and how well it worked and see what we could learn from that process. This is a diagram that kind of shows what we were thinking of in terms of our infrastructure for how the rules as code part would work. So the rules as code layer is the part on the far left, and there you have a reasoning engine like Open Fisca and an encoding of the rules, and that gets delivered as an API on the web somewhere. So that becomes an application that someone can send a question to, and it'll send an answer back. Skipping over to the far right, that's your application. So that's where you display pages to the user, you ask for inputs, and then that sends a message over to the rules as code side, gets an answer back, figures out what to do with that answer, and then does the next thing, whatever that is. And then in the middle there is what I was calling the application rules interface. So there's some amount of code, maybe small, maybe big, depending, that needs to know both how data is organized in the rules and how data is organized in the application. And it needs to do the translation back and forth between those two things. That may be very easy. It may be very complicated. In most cases, when it's easy, that layer becomes so thin that it actually feels like it's just a part of the application. So we were going to see, can we build a rules as code layer using Open Fisca for these tasks that will be able to hit all of those things that we've got in the middle box there? Can it deal with known and unknown facts Can it deal with questions? Can it provide answers, contingent answers, explanations, and can it answer questions about what's relevant? So what is Open Fisca and why did we pick Open Fisca? This is a very deep topic that I will only barely touch upon, but Open Fisca is an open source Python-based micro simulation tool. Micro simulation is a technique that's used for policy development in the public sector. And the idea here is that you are going to make a change to your tax or benefit legislation, and you want to know what effect that change is going to have. So you encode the existing legislation, and then you encode the proposed amendment, and then you simulate a number of small entities in that economy. So you, instead of simulating a macroeconomic indicator like inflation, you simulate microeconomic things like individuals, families, firms, incomes. So it's a high resolution simulation of the economy. And that requires dealing with a large number of data points for a large number of small entities. So a microsimulation tool needs to be able to do large data sets. And the other thing that a microsimulation tool needs to do is it needs to be able to deal with the passage of time. It needs to predict how these tools are going to, or how these laws are going to change the state and how the state is going to impact on the calculations going forward through time. So those are the two things that you really need out of a microsimulation tool. You need something that's good at dealing with lots of numbers all at the same time, and you need something that's good at dealing with the passage of time and how rules and facts change over the passage of time. So that's what Open Fisca is. Why did we pick it, despite the fact microsimulation is not really what we're doing? Well, it's kind of one of the most popular rules as code tools out there. It's certainly the one with the widest adoption. It's got very good documentation, very good community support, and very importantly for my context inside the Canadian federal government, it had already been used in my department, which meant that I didn't need to go through any process of getting permission to use a new piece of software, which inside a public service can be just impossibly long and tedious. So it was something that we had, it was something that we could already use, and that was a major factor for why it got used. Now, as I said, it's a microsimulation tool. It's not an expert system tool. So there were some challenges. The first challenge is that Open Fisca, in order to be able to deal with a lot of data all at once, is based on the NumPy library for Python. And that works very well for dealing with large quantities of data, but it also prevents you from being able to express the idea of, I don't know. There is not even a null available when you're dealing with NumPy. The closest thing that you can get is 0. And in Open Fisca, all different data types are represented as numbers. So if you're dealing with a date and you don't know the date, NumPy assumes that the numerical representation of the date is 0. That's the closest you can get to unknown, which means that in Open Fisca, the closest you can get to an unknown date is January 1st, 1970, which clearly isn't unknown at all. It's just wrong. So that creates a problem when you're trying to deal with other relevant questions and with contingent answers, because other relevant questions and contingent answers depend on being able to tell the difference between pieces of information that were provided by the user and pieces of information that weren't. The second problem is that Open Fisca doesn't have explanations as a built-in feature, so that we were going to have to figure out how to deal with that. And then the third is that the typical way of encoding legislation in Open Fisca didn't really provide any way to link the calculations back to the source material. So we needed to figure out that problem as well. So the question was, can we use Open Fisca for this task and get everything that we need? And the answer is yes. We found a way of doing it. I won't get into the technical details too deeply here. If you're interested, they're in the paper, which is linked and has been provided to the attendees. And I'd be happy to chat with you about it. This slide kind of shows the broad scope of what we did. So typically when you're writing Open Fisca, you're going to create variables for the things that are inputs, and you're going to create variables for the things that are conclusions that you're trying to draw. And in order to be able to do what we needed to do, on top of inputs and conclusions, we needed to also create variables for conditions. such as whether one thing is greater than another thing. And we needed to create variables for legislative parts and legislative subparts, named and unnamed. The second thing that we had to do is we had to take all of those variables and then we had to duplicate them in a completely separate set of variables. And those variables were just for the purpose of keeping track of whether or not we actually knew the value of the first set. And then third, we had to use OpenFisca's debugging tools in order to steal enough information about how these variables related to each other in a calculation in order to be able to come up with explanations. And that got fed into a directed graph, and that directed graph is then analyzed in such a way as to be able to generate a tree-based explanation, a list of relevant inputs for a question that we can't answer yet, and contingent answers. That's the basics of what we did. I'll just kind of show you very quickly what it looks like in practice. So the rules as code side, that left box, is running on a server somewhere on the internet. This Colab is running the middle box. So this is the code that's sending requests to the OpenFisca API and then doing all that graph manipulation in order to convert it into the things that the application actually needs. And then we have another Colab, which is playing the role of the client. So here you can see we're just saying that's our middleware location. And here we have some data. And so I will run this code. And you see we get back answers for 4 different benefits. We're just going to focus on OAS. That's the old age security benefit. And the answer with no data is more information required. And so it's able to recognize that there's information that hasn't been provided, and it's able to say what additional pieces of information would be relevant. So the first thing that we're going to provide is an age, say that the person is 65 years of age. Run it again. And now the app gets a different list of relevant items. You can see here, one of the items is whether the person is eligible under a social agreement between Canada and a different country. Now, if we say that the person resides in Canada, so the application has decided to ask place of residence next, it collects that, it sends the request back. It's still more information required, but because the person lives in Canada, the question of whether or not there's an agreement with another country is no longer relevant. So that's been removed from the list. And then if we just quickly add in the rest of the relevant pieces and run the code, you can see it says now that the person is eligible, and because they're eligible, it can calculate an amount. And the way that the application wanted to display it to the user was that if the answer was yes, you don't really need an explanation for that. People are happy. So the explanations are only provided when the answer is no. So let's change the answer to no by saying that the person has only lived in Canada for 9 years. And we can see it says the person is not eligible. The detail is they must meet the year requirement, and the reason is years in Canada. So these are variable names that were being used in the front end in order to figure out what text to display to the user to explain the conclusion. And then we can also show what contingent answers look like by changing the person's place of residence to Greece. So if the person lives in Greece and they have lived in Canada for 20 years, then they are conditionally eligible. And it has calculated that they are conditionally eligible because there is one unknown relevant factor that the middleware knows the front end is not going to collect. So the answer is you're conditionally eligible if you are eligible under the social agreement with Greece. So that's what we were trying to build. Again, if you're interested in a deep dive in any of this, all of the code is open source and it's all linked in the paper. Let me just go back here. So what are the upsides to this approach? It does work. And it's easy to deploy because OpenFisca was relatively easy to deploy in our environment. The downsides to the approach have to do with the way the code is structured. In a default OpenFisca environment, you might calculate whether or not a person was a minor on the basis of their age, and you might calculate their age on the basis of their birth date. For us, we need to change that in a couple of ways. First, we need to say the person is minor according to a section of law, which it's not usually just one section of law. So we usually have to add a bunch of variables for all the different sections that might be triggered. And then we say not just that there is an age, but the relationship of the age. The age is below minimum. So that's a condition that we need to encode as a separate variable. Age is still a variable, birth date is still a variable. And then once we've done that, we have to duplicate them all to create another variable describing whether or not that variable is known, and the known variables all have to be calculated in a different and very complicated way. So what started out as 3 variables turns into at least 8. To give you an idea of what this looks like practically, the code on the left encodes the statement on the right. The age requirement is satisfied if the person's age is above the eligibility age. That seems like a lot of code to say something that seems relatively straightforward from the perspective of the person doing the encoding. And it turns out it actually is. By comparison to some other tools that I've used, using this approach to Open Fisca causes you to write more than 4 times as much code as you would need to write in other similar tools. About a 300% increase. On top of that, the known variables are very difficult to, the code for that is difficult to write properly. And if you make it easier on yourself, you also make the code longer by adding more variables again. So you're between a rock and a hard place. And the big concern is that longer, more complicated code gives you more room for errors. And even if you can write the code perfectly, you're not worried about getting a lot of errors in it. The net result that you end up with using Open Fisca in this way is still less functional than if you had written the code in another language that was specifically designed for building expert systems with. So our conclusions about Open Fisca. Open Fisca is very good at the thing that Open Fisca was designed to do, which is microsimulations. If you have a lot of data and you need to calculate them very repeatedly and over periods of time, Open Fisca is good at that. But for the rules as code project more generally, Open Fisca is not the tool that does everything. It's not a Swiss Army knife. It does the thing that it's good at well, and it doesn't do expert systems well. We definitely need to keep working on other alternative approaches for this. And that's why, since working on this project, I've been working with the people at the Canada School of Public Service on upgrading blocks so that we could use blocks as a kind of demonstration tool for this kind of work. And that, I will leave it at that and stop sharing. And if we have a little extra time, I have like about a 2-minute demo of blocks that I could do at the end.
Thanks, Jason. I guess, do we have any questions first from either the physical or the online audience? I think people just want to see your demo. Yep. Yeah. So maybe we go to
sure. Let's do it. Okay, so this is a version of blocks that was released less than 24 hours ago. And so forgive me if there are bugs, but this is the first version of blocks that has been designed to combine a declarative logic encoding of a rule with structuring the rules according to the actual legislation. So I like to use rock, paper, scissors as my version of Hello World. So we're going to open up the Rock, Paper, Scissors Act. And you can see under this act, we've got 2 tests. One is called Bob Jane. So this test says, we know that there's a game called Desk Game. We know Bob and Jane are players. We know that Jane threw rock and Bob threw scissors. And then it has a query. Is it true that the winner of Test Game is somebody that we will call winner? And if you run this code, blocks gives you an answer, and it explains that answer in English. The winner of the test game is Jane, because Jane played, Bob played, Jane threw rock, et cetera, et cetera. So this is pretty straightforward, easy to understand. The question is, where did all these blocks come from? How does blocks know that a game is a thing? How does it know that a player is a thing? How does it know what through means? How does it know that rock, scissors, and paper are things? And the answer to that is the encoding of the actual law. So we go up here into the code editor, and you can browse the code editor by the sections of legislation. So this is our pretend act. You can see that if we go to section 1, a game of rock, paper, scissors has 2 players. So that's been encoded here. So we know that a game is a category. We know that a player is a category. We know that a game has players. And then there's a way here to customize the way the player attribute shows up, so that when you go into known attributes, it says the winner of game is player. So you can customize the language here, and that's the same language that gets used in the explanations. And then you can see we have created a category called signs on the basis of this text. And then 2A, we know that rock is a sign. 2B, we know that paper is a sign, et cetera, et cetera. And then you go down to section 4, which is quite complicated. This is the first time that we learned that a game has a winner. It's the first time, oh, I'm gonna break my code. It's the first time that we learned that a player has a throw. And then it's also where the actual rule for calculating a winner is. So we know that if there's 2 players in a game and they throw 2 different throws and the first throw beats the second throw, then the first player is the winner of that game. So that's the encoding of the actual law. And then it allows you to go and run those tests and get those answers. But in addition to being able to do it with concrete data, it also allows you to do it with abstract data. So we can say, assume that there are players in games, and assume that players throw signs. Given those assumptions, is there a possible scenario in which a game has a winner in the abstract? So it's important to note here that what we're doing is we're reversing the logic. In most computer programming languages, when you write a function, the function has inputs and it has outputs. You can change the inputs and get different outputs, but you can't provide the function with an output and ask it what the inputs might be. But that's what blocks lets you do. So we can run this code and say, in the abstract, how might you win a game of rock, paper, scissors? And from that same encoding, it's able to tell that there are 3 ways. Now, this is ugly text that I'm going to have to improve, but you can kind of see down here. The first way is rock beats scissors. The second way is that paper beats rock. And the third way is that scissors beats paper. So the same rule can be used to calculate the result of a specific fact scenario, and it can be used to generate a fact scenario, or more than one, that satisfies a given legal conclusion. So it can be used for planning, it can be used for expert system development, it can be used to generate tests against other pieces of software that need to be compliant with these rules. And it does it in a way that hopefully is intuitive and readable for people who don't consider themselves programmers, but do consider themselves experts on the subject of the law. And that's that.
Great. Thanks, Jason. And are there any questions? Really, really exciting stuff that you've shared. You have a question from Corina?
Can I just speak like this?
Jason, can you hear the question?
Okay, so hi, Jason. Thanks for the presentation. Very interesting. I have a question regarding blocks, or rather what you might do with it. And so the demo that you showed assumed that most of the stuff is really crisp and it's like sharp logic, but there's a lot of indeterminate or kind of open language also in a lot of statutes. And sometimes you might say that it's really like there's a higher probability that a certain outcome will turn out to be true given certain facts. So is there any way to deal with kind of non-determinism or probabilities to model probabilities in these kinds of systems?
It's technically feasible to do a form of probabilistic programming. I haven't implemented what you would need in order to be able to do that inside blocks, but it is technically feasible. And it's something that I'm looking at further down the road, only because there's some more useful things that need to be added first, like the ability to deal with dates and the passage of time. So it is technically feasible. My experience is that when you talk to people who are inside the public service and you talk about what it is that they are trying to build, they are perfectly happy not to ask questions that they don't think the user will have the answer to. And if that's because the question is a subjective one, it'll be decided by a decision maker, then the practical way that you approach that is you model it as a variable and you assume that it may or may not be true. And then you calculate your answer and figure out if your calculation includes any of those assumptions. And if it does, then you just say to the user, the answer to this question may be yes if the following things hold, including the minister decides that it's reasonable to, so on and so forth. And so in a low-hanging fruit sort of sense, we don't need to be able to deal with vague concepts better than that in order to be able to provide a very, very big amount of value for people who are trying to automate things inside the public service. We can do that, and I imagine we eventually will, but honestly, it's kind of like advanced mode.
Okay, well, thank you for your answer, very interesting.
We have a question from Guido as well on the online. Simply muted you, sorry.
Can you hear me?
Yes.
Okay. Thank you for the presentation. I have a couple of, I have a question and a comment of your last comment itself. So let me start with a comment. Now, very often when you deal with, let's say, legal document, legislative instrument, and in general, norms, those norms typically define what is and who has the burden of production. So essentially, in most cases, those acts, the norms, they specify what information must be provided and by whom. So yeah, so I'm not going to ask a particular question because it's up to you to provide it. Or in some other cases, something will be assumed by default, for example, presumption of innocence. So those there will be a particular aspect, but then when you look at a more complicated code, in most cases, you have explicitly who has the particular burden of production. For example, in Australian codes, what you do, you have typically a description of a particular section, and then you have two specifications. One is what is the offense, and then what is the defense. So this means that one of the two parties has to provide the particular information. So if it's an offense, essentially it's to the prosecution to provide information. If it is a defense, it's to the defendant to provide information. And essentially you are not going to ask unless the party provided the particular information. Now, in administrative cases, it might be a little bit different. And then in most cases, it's, and then there is a big example in Australia about the Robot Act, where there was a big assumption. So we are not going to ask, and actually the truth is that they were not able to get the data from other government databases, where it resulted in big debacle and $1 billion in compensation. So that was the first comment about this. My other question is about, well, in most cases, when you deal with, let's say, normative documents, you have to consider, let's say, the concept. So what are the obligations, prohibitions, and permissions that apply in a particular case? So for what I know, those are not possible to be done in an efficient way in Open Fisca. But what about in blocks? Is it possible to represent them?
It's possible to represent them. It's not something that I've experimented with yet, but it's absolutely possible. You can create obligations as a category with properties about the person who holds it and, you know, the deadline by which it must be met, the consequences if it isn't. You could model all of that within the structure of blocks. That's, I think I would also count that as advanced mode. The primary benefit to my mind of having an explicit encoding of those deontic concepts is if you are in a situation where you need to be able to ask questions like, have we inadvertently required something and prohibited it of the same person at the same time? And that's useful to be able to determine from the encoding, but it's not in the category of low-hanging fruit. The things that we would like to be able to do with these kinds of technologies in the short term, they tend not to deal with multiple parties. They tend to deal with one person who has all of the relevant information. And there doesn't tend to be a lot of issues about overlapping obligations. So it's something that I'm looking forward to exploring with blocks. But again, it's, you know, depending on resources, we might not get to it very soon. And I will say too, with regard to your comment, it really does come down to that question of the low-hanging fruit. The problem that we're trying to solve is typically not one where there are going to be disputes over evidence or questions about who needs to provide what. And so that gives us an advantage. I see that Ron has a question.
Unmuted and got muted again.
Yeah.
Can you hear me now?
Yes, we can.
Yeah, okay. So the question is just with relation to micro simulation. What is it that the rule-based systems don't have the capability to do in that regard?
So I can't speak categorically about it because I haven't tried to do microsimulation in rule-based systems. My understanding is that the microsimulation task it involves automatically generating a large population of simulated data on the basis of the prevalence of certain things happening. So you might imagine that there is a certain life expectancy at different ages. A certain percentage of the population will pass away before reaching a certain age. So that value, the percentage of people who survive from 81 to 82, becomes a factor in the calculation. And then you have a population of, 100,000 individuals. And so that percentage of 81-year-olds will survive to 82, and the rest will be simulated as having died. So it deals with very large quantities and a lot of calculations being done all at the same time repeatedly. So my understanding is that to facilitate that, you really need to have something more than the typical approaches that even imperative programming uses. It's not enough to just use Python. You have to use something like NumPy that allows you to deal with large quantities of data simultaneously. I'm only aware of OpenFisca and another programming language that's used inside the government of Canada called M++, but my understanding is that that's the kind of problem that those languages are designed to solve, to allow you to do very, very large data set calculations in a tractable amount of time.
I mean, so can I characterize that answer as saying that what it can do is you can put in a short description of what the distribution is like, how that distribution is constructed, and then it will generate that distribution and then run a whole lot of examples out of that generation. So you don't have to actually provide a big database of all the cases. It will actually sort of generate a sort of a distribution.
That's my understanding precisely.
Okay, thanks.
And as I say, I haven't tried doing it in rule-based systems, but you know, I kind of trust the people who are working on that stuff, that they know why they're doing it that way. It's that rule that if you find a fence in the middle of the road and you don't know why it's there, don't take it down. There's probably a reason.